In problem 14.2, we are told that a function a gives the distance of the input x from 0 on the number line. Now this should feel pretty similar to what we just kind of talked about, but let's go ahead and check it out. So if I think about the input 8, how far away is that from 0 on the number line? Well, it's 8 away from 0. Or the other way I can go with this, if my number was 5.6 away from 0, well, the number could be 5.6. But there's another option here, because there are actually two numbers that are 5.6 away from 0 on a number line. The other number that is 5.6 away from 0 is negative 5.6. So there are two potential values of x that could have an output of 5.6. Now we can continue from here. Pi, which if we hope we don't remember is about 3.14, is pi away from 0. 1/2 is 1/2 away from 0. When we get down to 1, we again see what we talked about above. If my output is 1, there are two numbers here that are 1 away from 0. 1 and negative 1. Those could both have been my input. I'm going to finish filling in this table and we'll be right back. I finished filling in the table, and one thing I want to point out is you may have noticed on the bottom half here, we started to get into some negative numbers. So like negative 1/2, for example, right here, gave us an output of positive 1/2 because negative 1/2 is still only 1/2 units away from 0. So now we're going to go ahead and we're going to graph this. So we just go ahead, we start plotting points. If the input is 8, the output is 8. If the input is 5.6, which is right around here, then the output is also 5.6. But remember we said there were 2 points that kind of went along with that. Negative 5.6 also lines up with positive 5.6 up there. And we've done this graphing before, so again I'm going to pause and jump ahead a little bit. So I finished filling in all of the points that we had from this table of values. But now I can actually go a step further here because they ask me to sketch a graph of function a. And these are not the only numbers that are on function a. Remember, they just gave me some examples to consider. So let me zoom in a little bit here. And if we think about it, there's no reason that I can't plug in any number like 5.073 and get an output of 5.073. So really, this is not a bunch of dots with gaps between them. This is a continuous function with infinitely many points on the line. So I can go ahead and connect the dots here, and this should be a nice straight line, but my drawing is just not perfect. It should look something like this, with again the graph meeting at a point down here called the vertex. So this V shape, not just a bunch of points that kind of make a V, this V-shaped line or set of lines is what an absolute value function looks like. And this goes on forever. I could plug in 1,000,000 to this, or 10 billion if I wanted to, really, really big numbers, positive or negative, and it will keep going to the left and to the right. The second part of this question talks about Andre and Elena, who are both trying to write a rule for this function. So we want to check these two rules. Well, let's start with Elena's. Elena wrote a of x equals the absolute value of x, which we actually just used that same notation in the last problem. This is exactly what the absolute value does. It finds how far away a value is from 0, because even if your number is negative, that's how far away it is from 0. So we can say for Elena, the absolute value of x finds distance of x from 0 because it makes all negatives into positives to get rid of the negative distance so that we don't have negative distance. For Andre, we can say something pretty similar here because we actually put this example in the last example as well. I want to focus on the two separate pieces of this. For Andre, this one, if x is positive, we leave it alone. You just have the answer be whatever x was. And this is saying if x is negative, then you find the opposite. Because again, a negative of a negative will bring you back to being positive. And that could pretty much be our answer down here. So that is our explanation for why both of those work. You could obviously add in other things if you wanted to, but that kind of justifies why they work here.